Thanks for joining, everyone. Soon I okay, I'll do it like this. I'll hear myself. I found that Salesforce is adding GraphQL to their platform soon. And I figured reading all the documentation is a lot, so I figured why not invite Peter, who's going to explain everything to us. Peter's an old university friend of mine. We worked together there, studied together there. And he's a, I would almost say, evangelist of GraphQL.
Good say.
He's the director of an agency here in Amsterdam, Lifely. They do a lot of cool front-end stuff. I don't know if you're mentioning that as well. Feel free to plug a little. And take it away, GraphQL.
Sure. Thanks so much, Sven. And thanks so much, the audience over here. I don't know if everyone's seen this. We've got a full house of people counting two. So please wave at the participants over here, that everyone knows that you're looking as well. Yes, I see some hands waving. That's good. Let's see if everyone can see me properly as well. You've got two views of me, one from Sven's laptop and one from me. So you can see both sides from me. All right, so let's get started, everyone. My name is Peter Peerdeman. Where do I have to look? I have to look here, of course. Hey, my name is Peter Peerdeman. I'm the technical director of Lifely. Yeah, so as Sven already mentioned, an old university colleague of mine, where we try to give some courses as well to earlier years. And here we are at the Emakina. So thanks so much for having me. I think it's really fun that I've been invited over here to see if I can spread some of the evangelism of GraphQL. I've given a number of talks on this topic. I'm super enthusiastic about it, and we started very early with this. So I'd love to share something about it. If you have any questions, please either speak up in the microphone or collect them for later, and we can do a little feedback round at the end. But first, a little bit of information about me. My name is Peter Peerdeman. I'm a bit of a data hoarder. So as you can see, one of my latest projects is collecting some data in InfluxDB and then graphing it out. So you can see the parking spaces in Amsterdam PR North, and you can see that you have to be there at around before 9, before the earlier tariff expires, and you have to pay more. That's something that's yes, fun to do. At the meantime, I also like doing some music production, so you can check out my alter ego, Tato Music _ where I do some live electronic music. And then, of course, my biggest project is I just got a kid, so he's now 7.5 months old, and it's basically taken over all the time I had before, preparing GraphQL presentations, doing music production, data hoarding, and it's basically just these emojis times 365 at the moment. So that's a little bit about me. A little bit about Lifely. We're a digital product studio in Amsterdam. Just moving from the Zekeringstraat, which was a little bit closer to here at Westpoort, to Prinsengracht in Amsterdam, trying to build some community and place where people come to meet and do some meetups, both with clients, but also with our competitors or colleagues, or give or take, to see what we can do together there. And it's, as Sven already mentioned, a mix of UI, UX, front-end development, a little bit of APIs, and when we do in GraphQL, of course, and a little bit of ops, but we're trying to do this more in a network way from now on. So we've got people who do things in concepts, designers, developers, engineers, and managers, a bit of the split up that we have. Super young team, now about 20 people big, with about 2/3 being development. Just to get a little bit of an idea what we're doing. Discovering success, building success, and also taking over success. So trying to come up with a plan how our clients can go on without us, or can go on with other colleagues with a certain project that we started. All right, so to the content. Basically, the reason why I'm standing here is that building APIs with GraphQL has been awesome for us. There's a couple of big projects that we did with GraphQL. One of them is TopTaal. It's a language course, a language institute. That's the biggest language institute doing Dutch for second language. So they put together courses, teachers, and students, and make sure that they learn the Dutch language, all done with GraphQL. Then we have the Ministry of Defense, where we created a vehicle maintenance application. It's a mobile application talking to a backend, also programmed in GraphQL, which was kind of like a pilot project. When you do a pilot at the Ministry of Defense, it's already full production ready, ready system. Then we have another big project of ours. It's called Ruler, which is a compliance platform. So if you're into compliance, they also did pretty good during the Corona crisis, because it's just also more laws to adhere to. And on this platform, you can basically get alerted when the law changes. They have some smart scraping algorithms that make sure that people get notified when law changes, and that you can record your current status of your control on this these specific things that you have to adhere to. All done in GraphQL as well, so big SaaS platform. And then we did some consultancy for Mr. Green and for Elanza, who also wanted to do stuff with GraphQL. So that's a kind of like the background that we have at the moment. And I just wanted to give you a little bit of a background on what we did before. So in 2013, we founded. We basically started out with Node.js because I was a firm believer that JavaScript was the future, especially because it was possible to create JavaScript on the backend and JavaScript on the front end. So you could have one team that's more, full stack, or is able to cross over a lot easier because you talk in the same language. So we started with that, and then we stumbled upon Meteor. Who here has ever heard of Meteor? Just a show of hands. A little bit. No. Any hands on the back? I don't see any hands. Right? Yeah, I see one. Georgia has heard of it. It was a very cool. Oh, I see some hands waving as well. That's nice. Thank you for that. Meteor was a full stack JavaScript framework in which you could create a real-time application in about 100 lines of code with both front-end and back-end code in it. And we thought it was pretty cool. We were one of the few companies, I think, in Holland that actually did some production work in it together with Q42. So it was quite experimental, but there was a really cool thought behind it. Then Meteor introduced GraphQL, which was quite new at the time, 2015. And that's also how we got interested, because we were working on Meteor and we heard the team. They were sort of fiddling around with GraphQL. And that's when basically Meteor got replaced by Apollo. So the Meteor team that was working on Meteor now was working on Apollo. And that's when sort of this GraphQL ball went rolling. So then we switched to native, how do you say this, vanilla Node.js with Apollo and GraphQL. And 2020, guess what? We'll still here. It's still Node.js. It's still Apollo and GraphQL for the stuff that we do in the backend. Then for the front-end technologies, it matches really nice with React. So we have React on the left, React Native for mobile apps, both using the Apollo client that interface with GraphQL. Just a little bit of history, because it's been quite new. GraphQL has not been around that long, but yeah, we've been super early adopters there, and we really had a moment where we sort of wiped the sweat off our face when GitHub exposed their public API in GraphQL. It's like, okay, a little bit of validation from the market that it's actually something that's worth looking into. Next to Facebook, of course, we introduced it. All right, so onto the why this actually was created. So back in the day, maybe I can look at Sven here. Back in the day, everyone wanted to be as RESTful as possible, because RESTful APIs was the thing, or being as RESTful as possible. But REST has some serious problems. Let's see if I can go. No, it's okay. So REST has some problems. So one of these is a nested data. So basically the callback hell, pyramid of hell. Finding data that's nested inside other data when you truly adhere to a nice REST spec, you have to do multiple calls to get subsequent data, which is just very bothersome and something that's, you have to basically hack it in a REST to really make it embedded in a nice way. I'm just going to zoom this a little bit to make sure that it looks better. Mysterious query parameters has also been, yeah, does it still show on the screen? Yeah. Mysterious query parameters. So you see API dashboard. Ook maar even uitzetten. The course data is true. That's how you could hack it. So you have a REST interface. You say course data is true, last enrolled is true, due payment is true, and then it would nest all that subsequent data. And then you would have, you know, a filter because you wanted to show less of the data on mobile. And then you have some random undocumented parameter that no one knows anything about. But if you pass it, then well, something comes out, and that's great. But no one really knew about it or knew how to use it. Then you have the random response format. So this is a little quiz for everyone. This was the URL that I encountered, and I saw this coming. So it's a get load task mode day page load is true. What do you expect with what's returned from this REST endpoint? Of course, it wouldn't be fun if it was just a beautifully designed JSON file, of course. So it's just a big, it's a big div with all things happening over there that you would not really expect from such an API. But hey, you got this endpoint, and it returns some kind of data. So it is RESTful in the end. So yeah, that was that's where I thought like, okay, excuse me, but yeah, this is of course around everywhere. All right, then we have the entityless methods with side effects. So that's basically doing a post to your REST API. I remember fondly when they were designing the API of Twitter, and they said, yeah, you had to, when you want to favorite a tweet, like how can you create a RESTful way of favoriting a tweet? So it would be something like /tweet/ID and then /favorite, and you would post to it, and then something would happen in the system, and 1,000 things could have happened. Notifications were being sent, the thing was being favorited, and maybe your last favorited one got deleted because it was an old one. I don't know, but these kind of things were never really very pretty in the REST spec itself. And then of course you had the versioning and legacy support. So first you had an API v1 and everything was great. Then you had the user, you had the v2, and then you had to sort of make sure that all these calls were still working. Sure, keep those working. And then you have v3, and then basically you got into this game like, please don't make me remap all my legacy fields again, and so forth for all the subsequent versions. And then in the fourth, of course, you did it again. And well, the pattern repeated itself a little bit. And then for the final one, documentation, I have to be honest, in the beginning it was a bit bad, but Swagger was kind of okay, and it's still okay. So if we have a nice way of defining a REST spec now, and I mean I'm not here only to bash on REST. If you create a good Swagger documentation, it is fine. You can do your stuff, but it's not as, how do you say this, made for it or something. Or Swagger documentation is also something that you have to update to keep it in sync with the code that's actually there. You can do some clever things with generating it from your code, but then still you have to make all the annotations. Well, that's the thing about REST. All right, so what are we talking about today when we've introduced all these problems? So GraphQL, basically a query language for APIs, and everyone has a different way of explaining it, but this is what this is my take on it. So a query language for APIs, and what does it actually mean? I used to have some slides here trying to explain, but on the website they made these awesome videos or animations that really shows it very well. On the top, you create a query. And you say exactly the resource and the fields that you want in your result, and then the result you get back exactly contains these fields. So instead of going to /API/hero and getting back this whole hero entity, you just say I want the name and the height, and then you get back those details. And that's really cool for selecting one entity. But you can also group these, so you can also have multiple queries that you aggregate into one big request, and you get all this data back at the same time. So as you can see in the example, you can have the hero, it's the name of the hero, but also the friends of this hero. Specify this and then retrieve both the entity and all of the friends of this entity at the same time. And you could even have a completely different entity also aggregated in this result, which is great because you have fewer round trips to the server. When you're on mobile, you only have one time that you fetch data and you get it back, so you don't have to send multiple requests or wait for this round trip every time. Then one of the biggest parts, or the things that I'm most enthusiastic about, is the type system. So what you can see over here is that every field that you request in the API is strongly typed, so you know exactly the type of the field that you're going to receive. So it gives you the documentation and you know what to expect. So when you're coding your API, when you're coding your front end, or even generating your front end, you know what kind of fields you're going to get from the API. Because you're adhering to this GraphQL spec, you also know that you cannot return a string when it says that it's going to be a number, because then the GraphQL parsing at the backend will just, give an error like this is not returning an integer, so it will not work. And then my mind was even more blown about showing off the versioning, which is cool. So bear with me for a second while we wait for the GIF to sort of cycle through completely. What you're looking at here is a director field on the film type that is being deprecated. So first we created the director field, then we had the directed by field that we added and we wanted to change. And basically you can show with this typing of deprecated, you can show this field is going to be deprecated in the future. And at the same time, you can already use the new field. So it's basically on the field level and on the entity level, you can sort of version your object. And of course, this is not a perfect, but it is a way that's maybe a little bit more sensible than completely doing away with your entity and making it v1 and then having a completely new object, even though the rest of the object might be similar to what it already was. All right, and then good standards need good tools. I think one of the reasons why REST is such a nice way of working is that we have all these tools that help us with this, like Postman and Insomnia and all these tools where you can keep your ledger of calls and replay them and sort of figure out all the details. I think that the reason why GraphQL stuck is that they decided to postpone the launch of this whole spec before they had the good tool. So they created this tool called GraphQL, which is a graphical interface of interacting with the GraphQL API. Which is a really nice tool, and you really need this tool to really make sense of this technology. So that's very cool that they sort of thought, I'm going to do this tool first, and then we're going to release it. So here I've created a video of how GraphQL would work. What you basically see here is me typing in one of the APIs of the course administration system. And what's most interesting is that when you see me press control space, it will actually autocomplete what is available in your API. So it's not possible to create a query that doesn't work. It will just say a red squiggly line and say, hey, you need to have a search text there, or you need to supply a certain parameter. And in this editor, these things get auto-completed, and you can very quickly create your query and check if it works. So if you play the play button on top, you will actually see the response that you're getting from the interface. And then from that moment on, you can copy your query and put it somewhere in your client code to make exactly this request. So that's a very, very handy tool. And you have the docs over there folding open and showing you the rest of the API, but probably we'll get there during the demo, I hope. Oh yeah, I was showing here that you can have multiple entities in the same request. So both the groups and the course materials you can get back and add some limits stuff. All right, so just think about it for a second. We've taken everything in, and basically it boils down that any front end, so it could be a web client, could be a mobile, it could be your Fitbit, could be anything, can write its own query for exactly the data they need from the API. And that's where I think, yeah, just to let it sink in, it's allowing front-end teams to decide for themselves which data they are going to retrieve from your API, instead of having it to filter it after they get the response back, or asking the backend developer to exactly create an endpoint that will deliver the code back, or the response back in the way that they wanted it to have it. And I thought that's kind of a superpower. If you look at it from the front-end point of view, this is always when I sort of present, I see like the front-end developers in the back, like cheering and sort of throwing stuff and saying like, yes, we want it. And then the whole backend team is maybe a little bit more skeptical, because of course it's not all just fun and games when you start nesting stuff and getting access to data in all kind of different ways. But hey, we'll get there. Yeah, just to give a little bit of a perspective on how this would look. I will not go think too deeply into the code examples. If anyone wants to sort of completely nitpick this, it's probably, you know, there may be some errors in there, but just to get a little bit of an idea how you would use this kind of thing. If you would have in a vanilla JavaScript, you would create a variable where you would paste in the query that you've created in GraphQL. Then you would do a fetch to the endpoint. So it's always a GraphQL endpoint. It's always a post method. You would set some headers, or not set these headers if you manage it in some other way. And then you would supply in the body, you would supply the query and the variables that you're passing. And then basically you get back some JSON and do something with the data. So that would be the trivial example of just doing a post request, just like any REST API, with the difference that you specify what you want inside the query instead of in the URL. Of course, you can do this in a much prettier way if you do it declaratively and use something like React. Just a little bit of a show of hands. Anyone here with some experience with React or any React affiliated? I see one hand in the room over here. I see another hand waving and another one. Ty, thank you. Yeah, just to give a little bit of an idea, you have some helper functions over there, like the GraphQL tag that helps you build the query and recognize it. So your IDE will actually, I should put an animation of that in the presentation as well. But if you create this, your IDE can detect that you're writing GraphQL, can actually even connect to your GraphQL API, so you can autocomplete inside your IDE your query as well. So you don't even have to go into the graphical interface to create these queries. Then you would create a component. This component you would wrap inside the query component. So the query would then be the GraphQL query that you just created. There's some nice extras there. For instance, a loading state. So while the query is loading, you can show something. You get error if there's an error, and you get data if there's data, and then you can just return your DOM component, actually rendering the code, the results. So that's a pretty nice convenience thing, that you don't have to sort of do this loading stuff yourself. All right. That's great. Now show me something fancier, and we can probably go fancier than this. There's a couple of things in Apollo that's pretty cool. So Apollo is the client library that is interfacing with GraphQL API. So in your front-end code, you would include Apollo, and it will do some magic or help you out with some stuff. What I thought was really cool is that they have a super clean fetch more API, one of the most clean pagination APIs I've ever seen, about how you can paginate your data. Things like prefetching. So if you would hover over some content, you could already do the GraphQL call for the subsequent data, and then when you click it, you would already have it inside your cache, your data model in Apollo. Yeah, zero config caching. So when you do a subsequent call to the same kind of data, that it will just come back instantly instead of refetching it from the server, for instance, when you press back on a page that you don't have to reload it again. This one's pretty cool, optimistic response. So simulate the results of a mutation. This was also something that Meteor was known for, doing optimistic responses. So for instance, when you're favoriting a tweet, you could already in your front end guess that the favorite would already be complete, and then immediately show feedback and just roll it back when you had an error, instead of waiting for a response and then filling in the little heart icon to make it feel even more snappy. And then you have the subscriptions, which is real-time data, which was one of the biggest features of Meteor that they sort of, well, I don't think ported, but shape-shifted into something that would work with GraphQL. And that was something that I'm still pretty fond about. I was a proponent of this real-time movement a while back as well. So you have here the typical WebSocket example where you have a chat and you see some people putting in some data and showing the data on the other one. And this GraphQL supplies a standard way of exchanging this data between the client and server. Because probably just another show of hands, who has ever done something with WebSockets? I see 3 hands raised over here, so that's a 100% score over here. I see some hands. Yes, thanks, Bruno, Georgia. Emin, yes. Well, basically, if you do something with WebSockets, everyone always creates their own spec. They just send a JSON and then get something back, and you just think, oh, I think I need a name over here, so I'll just create the thing with a name over there, which of course makes it super hard to incorporate other APIs or to learn about other APIs, and you're basically left with the documentation chops of the person who created the WebSocket API to actually consume it. While GraphQL defines a very clear way of this is the way that you can create a subscription, and you could even create tooling to use these subscriptions or have systems integrate with these subscription APIs. So that's pretty cool, just to get a little bit of an idea. Just like the query that you had before, you also have a subscription where you can say when a comment is added, I want to get the comment that was added with the ID and the content, or just the ID, or just something else. And then you would get back this data the minute it arrives. So just for the people that really want to know how that would look in React, it's kind of like this. I won't go completely in depth there because I added some slides to the presentation that it's maybe more on an architectural level. But I found this really cool. So if you're interested in that, please look it up, because the real-time stuff is actually pretty cool. All right, now we go to the how, and maybe this was already a bit of the how, but I thought how would you actually use GraphQL in different scenarios. So there's a couple of things that you can do over here. One of the things that it's used for a lot is as an integration layer. So for instance, the Havia student app was one of the projects where we used this in integrating both direct database calls and legacy REST calls to systems that were already in place, but you wanted to have one uniform API where you talk to from the application itself. So if you would look at my beautiful stick figure thing, you have on the right, you had the existing landscape. So we had an OAuth server, a grade server, and a schedule service, just abstracted, and that's some stuff over there, which had their own REST APIs. And they sort of were aggregated inside this GraphQL integration layer. And then the fun part is that, well, there was a part that was not there to create suggestions inside the application. Well, what would the next feature be that should be developed? So we created a small Docker image with an application in it, which had its own had its own API, and basically plugged into the GraphQL aggregation server. And this is a very nice way of offering a very uniform front end for your front end team, so they know exactly all of the kind of bits and pieces of data they can use in their front end application, while still maintaining the ability to use REST APIs in the backend or legacy, or you can even have SOAP WSDL API behind it, or do some other like super old school stuff, RPC things. Doesn't matter as long as you return the data in the way that that's being requested in the GraphQL layer. So I think this is also just one of the things that would really work. And of course, this is not unique. You could also do this in a REST API. You can also create a REST endpoint, like fetch some data from Twinfield, and then go to the third party, get the data back. But in this way, it's very seamless as an experience for a front end developer. And you would not even know that you're actually going to a legacy system. Maybe only if the load times are a little bit longer. All right, so a different case for GraphQL would be, for instance, as a micro API for an existing server-side rendered application. It's one thing that we did in an app that we created a while back. It was a Python app that server-side rendered some pages, and we created a GraphQL layer inside there to create the basis for a new front end. So what we did over there, we had a Python platform which had a cockpit that was just rendered in server-side. We implemented the GraphQL endpoint that would expose this data through the API, and then add a new React application on top that would fetch similar data as the server-side rendered one, and even expose some new fields that were needed in that application. So this was also a way of using GraphQL to create a very nice working environment for the front-end team to quickly iterate and use some of the cool stuff that Apollo has to offer. Then maybe for the bigger environment. So what about the bigger corporates? What are they doing? I have to say this example might be a little bit older. I think it was 2017 or 2018. There was a talk given by Ugur and Tom about what they did at KLM, which I thought was very interesting. They were very sort of looking forward there, and really looking at the new technology and how they could use it at something as big as KLM, which I thought was very interesting. So the long story short was that it looked a little bit like this. So you would have a client with Angular applications, and you would have different servers, each with their own GraphQL APIs. So you had the search, you had the check-in, you had the checkout, and the profile, which were all separate silos. So they were all separate servers that they could scale independently, because some servers would be hit a lot of times, some servers were hit just a couple of times. So they wanted to be able to completely separate this, but they created GraphQL interfaces for each of these and then aggregated them together, so you could have one seamless experience talking to all of these different APIs. And they had, it was in the start, more in the start of GraphQL, so they also had some challenges sharing these types. So they abstracted these types away in NPM packages that were shared across all of these servers. And then you would have the APIs, like the real REST APIs, still being REST APIs. So the backend team could really focus on making sure that it's a very optimized, very high traffic REST API that would stand the test of time, and not basically well, it was still the question, like, is this GraphQL thing a fad, or is it going to go away? But it offered the front end team a great flexibility to have their own sort of front-end aggregation layer where they use GraphQL, and then let the backend people just create highly optimized REST services. And this might also be something that we'll be seeing a lot more, that the original APIs will still be REST, especially if you look at the Salesforce cloud, will probably still be REST endpoints, and then adding your own GraphQL layer in top, or having it inside the product as a GraphQL API. So I thought it was that was pretty cool. So for servers, independent scaling ensures you get only the data you need. That was an interesting part. So because they had this integration layer, they could specify what came back from all these different servers. So they wanted to make sure that as little data was sent over the wire for it to be even faster to the front end, and this would reduce network traffic, because it would only be internal traffic going from the original REST API to the GraphQL integration service. Yeah. and then had a little bit of a challenge of the shared types, but there's new solutions for that as well. All right, so then I was challenged by Sven to look at what's happening in Salesforce Commerce Cloud. So that was a fun experiment last week between all the baby stuff when the baby was asleep for a while. I looked into what was actually going on there, and I'm going to try to do a little bit of an elaboration on that. But mind me, I'm no Salesforce expert, so I'm just tipping my toes in here. One of the parts that I found really interesting is that we have a GitHub page for the Salesforce Commerce Cloud over here. They have sample apps over there where they show this is how you could build an app onto that connects to the Salesforce Commerce Cloud application. And they've actually chosen Node.js as a backend language and GraphQL as the API language that would connect to the front end over there. So that's actually a very nice look into how you could create such a backend application in Node.js and why that works well, and how you can elaborate on that further. So that was fun, and what was also a nice discovery was that they say they talk about this Salesforce Commerce Node.js SDK. So that's maybe a little bit where the monkey comes out of the sleeve, or where you find out what the thing behind it is. This is actually the stack that they propose. So this is currently the way Salesforce says this is how you can create an application that makes use of this Commerce Cloud. You would have your Lightning web components on the front end. Then you would use Apollo Boost GraphQL client. So that's the Apollo layer inside your front end application. Then Apollo would connect to a GraphQL Apollo server. So you also have Apollo on the back end there. And then inside this Node application, where you're using Apollo, you would use the SDK. So the official SDK to connect to the Salesforce layer. You would use the SDK to actually do the calls to the original endpoints. And then the Salesforce Commerce API would still, under the hood, be I think it's a REST API. They didn't go into that depth, but you would use the Node.js SDK inside your GraphQL application. So you could also create your REST spec, of course, and then use this SDK directly. So I thought it was interesting, and because I didn't have the demo of the web services, I thought, I'm going to torture myself again and see if I could do a little live demo of what was actually going on there to spare everyone, to have everyone experience, have a little bit of the experience of the demo time, the demo time gods that are going to be very friendly today. So what I did is I checked out this thing. So it's not that fancy. I checked out this thing, and what they say is you need, of course, you need access to a Salesforce Commerce Cloud environment, which I didn't. So I made up some of the, what is it, API example. I figured out that if you just put in 123, 123, then it will actually run the application as far as needed to make it work. So probably you guys could supply your test credentials over there, and then it would actually do something. And if you would run this application, you would get something like this. So what is happening over here? We have an application that has some content. You have a search bar on top. You have some catalogs that they basically hard-coded inside this front-end application. So there's no actual connection being made to the backend over here. And the idea was that if you would search for trousers, or you would search for a bag, then of course no search results because I'm not connected to an API. But it's interesting to see what actually the front end is doing over here. To see if I can increase the size on this a little bit. So what I was seeing is that an API is being called. So they didn't call it the GraphQL API, but it's just an API. A post is being made. You get a 200 OK back. And what's being sent is this thing that we saw before, like the structure of a GraphQL call. So what is one big string, which contains the query itself, and probably we could see this prettier in the code because it's all concatenated to one line. But you can see over here that it's a query and there's a call being made to the product search, and the query is being supplied, and you've got some filters that you're adding here. You get the product name back and you get an image, and that would actually retrieve this data. And then you would see a separate call that has the variables. So you see the variable query is back, and the variable filters is no filter because I didn't select the filter. And then of course the response is your your call to 123/123 doesn't work. So that's as far as the backend would go. But it's a demo of what could have happened if it was implemented that way. And when we look at the code, was something that I wanted to show over here. So inside the packages, we have a SFCC BFF, I think the best friend of this core API. And you have two APIs that actually have been implemented. So I was a bit maybe thrown off or sort of put on a distraction track, because it's an example application and it's an example implementation of a GraphQL API that is using the Commerce Cloud SDK. So what that means is they've got a basket API, so you can actually retrieve stuff from your basket, and they've got the product API where you can do a search for products and for product details, but it's not an extensive, it's not the GraphQL API for everything of Salesforce. The idea is you can use this example and then add the fields that you actually want to use or that you're going to use in your application. So okay, that's okay. But if we dive in, it's fun to see how the backend works of this GraphQL server. So I'm not going to go in the full code explanation, but what I found interesting over here is that we have a search product function, and this will in the end call the product search, which is actually from the SDK of Salesforce. So you see in the top, we're importing all the stuff from the Commerce SDK as Commerce SDK. And from this thing, we create a search shopper search, and that's basically the search clients that's being used to retrieve some stuff. So you can see over here, we have the Commerce SDK. There's a search, and in there's a shopper search, and you pass this client config. And then in the end, when you actually search for the product, so you see over here the query that's being created, the GraphQL query that's being created. You see, if you have this GraphQL query, you do this call, you get a query and you get some filter params, you get context for your authentication, and then the result that you're going to retrieve is actually the search product that we saw earlier, which is doing a call to the SDK with some of the parameters, and it magically returns a new search result with the results that came back from the SDK. So there's a couple of this schema points that's actually implemented, and you can look them through, and of course they all look sort of similar. But for the people that have worked with the Salesforce Commerce Cloud API, these things will probably look familiar, where you see that a product hit will actually contain an ID, a name, it would contain prices, and then interesting part over here is that you see prices being a type. And then the prices is probably consist of some other fields. Maybe we can look it up in a second. So it's actually defined very specifically what this thing will return. And then if we go back to the browser, and we go back to /API, so I've now browsed to localhost 3000 /API, we can actually see the graphical. Well, it's a bit dark over here, right? I don't know if I can make this inverted. Oei. Oei. Light misschien. Ah, it works. Okay. So we have the graphical interface that we saw earlier. So I can actually do a live demo of this now. So I'm pressing Control Space, and I can see the fields that we just saw were being exposed. And for instance, if we were to return the basket, we could now see that we have certain shipment IDs, and we would have products in there, and probably these products can show a price. And then what I thought was interesting was figuring out what this price would do. But of course, if we call it, we would get an error. But you could actually fold open the documentation on the right side to see if we would get back a product. It would, oh, here it would have a float. Okay, so maybe sorry, it's the prices one. Oh yeah, here you go. So inside this type prices that we saw earlier, there's actually a sale price and a list price, which is different floats. So I thought it was really nice that they made the effort to actually get you started on this, but not, maybe they're still working on the rest of the GraphQL interface that they may maybe even expose on the backend itself. But for the time being, it's just the aggregation layer, where just as easily you could add another field over here, which would get, I don't know, some third-party MailChimp mailing list number or any other API call that you can include in here and have one uniform way of accessing your data.
I have a question.
Oh, you have a question. Yes.
Once we have GraphQL set up for one of our projects, which generally always just consumes this one API that we saw, can we just use that GraphQL layer everywhere? We can probably, right? If this example would be complete, would any of us ever have to write GraphQL if there are no exceptions in the commerce?
Yeah, I'll repeat the question. So Sven asked the question: if we or Salesforce were to create this GraphQL API for all of the standard fields inside the commerce API, would we ever have to write it again? No, because that would be the implementation that would map basically the fields of the Salesforce API to a GraphQL API. And then you could, for instance, think about how would this plug into the custom business logic that we create for our clients, whether it be in some Python or Node.js or any other language. That would also just where you would stitch then the GraphQL API that you're creating and the basic GraphQL API that either was delivered by Salesforce or written internally that contains all the fields in the way that you want to expose them. So yeah, that's a good possibility, and it's also a way that a lot of the other GraphQL projects online work. If you, for instance, I just looked up Hasura. Don't know if anyone heard of Hasura. It's a company that just raised 25 million to further elaborate on their GraphQL generation API. So you basically pass it a Postgres database with a schema, and it will just generate a complete GraphQL interface for you. And then basically they say, oh, for all your simple CRUD things, you can just use your Hasura and generate it. And then you would have a hook that would maybe go to your custom application that does some extra things that Hasura can't do, for instance. Yeah, and then stitch these two together, and you have one API that works very well for your frontend team. Yeah, so I think that's about it for the demo. Any other questions so far? Got one more question.
My mic. One question. I'm curious about how the discovery of the types and everything works. Is it an automatic thing when you use GraphQL, or do you have to share a file like a WSDL file used to be shared? How does that work?
Here's again. All right, so the question is, how do you discover the types of your GraphQL API? There's actually a sort of a discovery that's being done while you're loading the graphical interface. So I'm going to see, I did not check this beforehand, but we're going to see if we refresh this page with the API there, it's actually loading the API. So if everything is right, we should be able to see the introspection call that's being made. I hope I can find it. API. I think this might be it. So here you see the first query that's being made to the API. It's actually the introspection query, which every GraphQL API adheres to, delivers this, which is a query that will retrieve a schema. You can see the underscores there. It's a sort of a proprietary, something that you wouldn't write yourself, but it will actually deliver the whole schema in in JSON. So, and that's also how they build the documentation on the right side. And this, so this is shared through the API itself, and it's of course defined in your server configuration. So when you're writing your server code, you have to explain these types, and when you're returning some data for these types, you have to make sure that it actually contains that same data, or it will just error and say, hey, this doesn't comply to the types you have defined. Yeah. That the query is auto-generated. Yeah. So you write it inside your you define the types inside your backend code, and then the query just works. Yeah. Any others? Maybe we can get into questions in a minute when I finish up this stuff. All right. So Lifely basically loves GraphQL for well, uniformity. I don't know. I'm just a sucker for getting everything in a nice uniform way. Linked data hydration done right, so you can decide yourself how far you want to hydrate your data object instead of either full on or not. Strong typing also is expectation management. So what I found very interesting is that front-end teams and back-end teams also can have this discussion about what should be in the API and how I would expect it, and it would show up in the documentation immediately. So you could even have some stub writing being done by the front-end team that says, hey, I'm expecting the data in this way, and then the back-end team could implement that, for instance. Automated documented API, versioning flexibility, consolidating microservices and legacy into one API. We talked about this before, of course. But most of all, the front and back end love. So the integration between the front end and the back end. It's just the way that they use these APIs. I mean, if you're a really good REST endpoint developer and you've got very nice Swagger documentation, you probably have some loving front end team as well. But we found that the iteration speed going through changes in APIs is really nice and optimized in that way, because you can clearly see this is here, this is not here. If I request this, it will only be there if it's implemented and showing up in the documentation. If it works, it's like this: documentation, handover. So you could actually see that just exploring the API is also quite intuitive, and you could just fiddle around and immediately see the data that's being returned. Yeah, front-end involvement in discussing APIs and contracts. So if you want to get started and want to get your hands dirty with this, there's a very nice tutorial by Prisma. It's called howtographql.com. So that's an easy one to remember. And if you want to dive a little bit deeper, there's advancedreact.com course. I'm not being endorsed by Des Bos, but it's just a super good tutorial using Advanced React and also explaining some GraphQL stuff. I should probably make this an affiliate link sometime. He's probably had some downloads through me, but that's a great place to get started. And of course, Lifely would love to help you out. That's you know, I'm not here to poach anyone. We're just trying to create a community and see if we can share some of this love. And we'd love to help you out getting started with this, or doing some migration, or just sharing some of our thoughts on a plan, for instance. If you're trying to migrate something, just having some extra eyes looking at this from the perspective of already doing this for about 5 years. Yeah, would be great to have a little bit of collaboration there. So that's it. Thanks so much. Thank you for your attention. Thanks everyone outside. All right. So the what, how, why, and the how. Maybe see if there's some questions from abroad, or anyone who wants to enable the microphone.
One question. Sorry.
Mm-hmm. Hello, Georgia.
Hi. Just a short one. Do you have any information about performance during transition between REST API and GraphQL? Because as I see in the beginning, payload is less, but we will have more requests sent because we are involving some layer from some integration layer regarding GraphQL.
Yep.
So do you have information? Will performance has dropped down a bit after starts arising.
All right, so I think everyone heard the question, but I'm still going to repeat it for here, right? Okay, so Georgia is asking like, what's the performance hit on using GraphQL as an extra layer? So that's a really good question. I think if you're working in a language like Node, which is really made for high performance, high throughput requests, actually the performance hit on just parsing the GraphQL query, resolving it, and doing a request through. That's not the heavy part. I don't have the exact numbers on this, but it's not a big, it's not a very big increase. Of course, it is a increase because you're going to hit another server. I think the biggest performance hit comes when you do one request and you're actually going to do multiple REST requests on behalf to sort of fulfill that resolver. For instance, I've also seen GraphQL queries where you would have 3 entities, for instance, and each of them showing an avatar, which is the same user. So you could actually, in a very worst case scenario, you could have one API call being made to, I don't know, the blog API, and then to the user API, and then to, I don't know, the last couple of messages from this user, and then hitting the avatar API for each of those requests. So actually 4 requests being made, retrieving the same data. So there's optimizations for this as well. When you see that you're going to load the same data to just do the call once and aggregate it for the rest of the call. But it's something that's where you're delegating this logic to the backend team. So it really depends on how well you optimize your resolver to query this data. But just the hit in front, it's just parsing the GraphQL structure to see, is it a valid request, which is probably the most heavy part. And for the rest, it's just a resolver that wants to get some data. So that the time it takes to get this data just depends on how quickly you can respond to the call that's being made. Hope this answers the question a little bit.
Yeah. Actually, yes. Thanks, Peter.
All right. Any other questions? I've not gone into the backend that much because usually I get all of the backend team quite riled up. Like, how is it with security and caching and indeed the performance? And we've had some nice run-ins with being able to access some data because you're able to access friends. So for instance, if you would program a friends query on a user, if you do not shield the profile details of that person, you could actually retrieve that through another query, which is something that you can also guard against, but it's just extra work for the backend team to make sure that you cannot access any of this data.
If you don't want to go into this too deep, I get it. But can you speak to the learning curve that is involved in the backend?
All right. So the question is, can I speak to the learning curve that is involved in the backend here? I think getting started is really easy. So just getting an endpoint up and running, getting GraphQL in there, creating your first resolvers and your first types in there is super easy. You can just follow the tutorial and you're up and running within no time. I think anyone who has ever worked in Node.js and knows a little bit about TypeScript helps. If you know about types or worked in another type-safe language before. And I think it really starts ramping up when you're going to do authorization on nested fields and really getting deep in the sorry? Well, it's mostly the Apollo server that's being shown as a module that can help you alleviate some of this. So for caching, you have the Apollo layer that already takes care of some of those things. But as everything in Node.js, there's a million packages for everything. So there's no like real opinionated way like this is how you do authorization in this. There's not. Yeah, you have to sort of see like what's most popular in the community, and that would be the one to go. Yeah, but it does boil down quite often that you roll your own. Yeah.
I have one question.
Yes.
How do you guys handle file uploads?
So the question from Bruno is, how do you handle file uploads? That's a good one. I'll have to remember if we had to create a REST endpoint for that, or that it was that we were able to do this through the API. But I think actually that you're able to supply it in a mutation. So it's the same as mutating data. So instead of query, you type mutation, and you have a field, and you can say, I've added a document, and then you just do a post of the document. But I'm not entirely sure here, so I'll need to look this up for you. I think in the early days, there was not a way to do this, and we still had to create a REST endpoint. But I think they fixed it now, because in the last project that we have, we do not have a REST endpoint, and there's file uploads there. So they figured out a way. They figured out a way to do it in that project.
Okay, thank you.
All right, so the question is there a limit on the amount of data you can send or retrieve from the GraphQL API? It's the same limits as Node.js request response. So there's nothing being added there about GraphQL itself. So you need to handle the stream, and if you post something in and you use a stream to transform it, it will work in the same way as Node.js. Yeah. Nice. Good questions. Being grilled here. It's very nice. Yeah, thanks so much. Yeah. Very nice. Any others? And else I would say grab a beer and join for drinks afterwards.
Given the time, it's a fantastic time to wrap it up. If no one has any burning questions, I want to thank you all for your time. It's amazing that we're still with 40 people around now.
Yeah.
And
very
then
nice,
there's
right?
still 10 people that actively ask me about the recording. So a lot of people are going to see this. Thank you for your time, preparation, knowledge, and insights. Very cool. I think this is really going to be a thing as part of the Salesforce landscape. We are never sure how it affects our clients directly because they're already up and running. But somehow we might give you a call if we're stuck or starting.
Very nice. Thanks everyone for your attention, and stay safe. Have a nice day.
Thanks very much.
Thanks, Peter.
Thank you, Peter.
Thank you.
Bye -bye.
All right.
Bye.
Thank you. Bye.
Bye.
Thank you.
Zo. En? Deze volgemaakt, hè? Ja?
I've heard about that.